In this video, we're going to talk about reading wiring diagrams. This is a typical ladder wiring diagram. It has the high voltage at the top. In this case, it's 240 volts with compressor, fan motors, and other relays. And the bottom is divided by the transformer, where you have 24-volt circuit. So all of your relays and thermostats are controlled by 24 volts. On some diagrams, you may have multiple control voltages where you may have 240 volts for the line voltage. You could have a 115 volt control circuit with a 24 volt control circuit. So make sure you understand what kind of circuit you're working with before you start working on it or trying to troubleshoot. The second type of wiring diagram is a component arrangement, which usually shows the physical position of the items in the control cabinet or in the unit itself. So here you'll find the various switches, transformers, control boards, fuses, heat strips, all the things that make up the unit will be depicted physically on the component arrangement diagram. There are volumes of symbols that are used on wiring diagrams. So in order to read a wiring diagram, you need to be able to interpret the symbols that they're using for various devices on the system. In this top view of the 240 volt circuit, we are supplying 240 volts to this system on L1 and L2. We have a compressor with the common start and run windings with a run capacitor, and it is controlled by the contactor contacts, which are in this case normally open. When the contactor is energized, these contacts will close and will bring on the compressor. We also have depicted here a thermal overload that is probably internal to the compressor, a click-on type switch that when the compressor overheats, it will open up and shut down the compressor. We also have the indoor fan motor with its associated run capacitor, and it is controlled by the indoor fan relay, which is in the 24 volt circuit. We have the outdoor fan motor or condenser fan motor with its associated run capacitor. It is controlled by the control relay and also by the defrost relay, which shuts down the outdoor fan motor during defrost. We also have heaters on this system, so you have HR1, which is a normally open contact that is energized in the 24 volt circuit to bring on the heat strips. We have a circuit breaker that is in line with the number 1 heater. Then you have HR2 and the normally open contacts, a circuit breaker in line with heater number 2. Then we have a control relay that is on the line for the crankcase heater, as well as a temperature switch that feeds power to the crankcase heat for the compressor. Now let's look at our 24 volt system. We have a 24 volt transformer that powers our control circuit. We have a thermostat that is wired into this system with thermostat switches that open and close on temperature rise and temperature drop. We have an outdoor thermostat which is connected to the heat strips, which will prevent the heat strips from coming on until the temperature is at a certain degree. We have the reversing valve relay. We have the defrost relay. You have your heater relays that energize the heat strips, as we saw in the upper diagram. There's your indoor fan relay, your control relay, your reversing valve contacts that are operated off the RVR coil. You have your control relay that controls the power to the contactor. You have your high pressure and low pressure switches. You have your contactor coil, which is energized when the control relay closes and the high pressure and low pressure switch is closed. We have our defrost timer. as well as the associated open and closed contacts for the defrost timer. We have our DFR, or contacts that are associated with our defrost relay. We have the defrost relay here with a thermostat that will allow the system to go into defrost at a certain temperature. And then we have our reversing valve relay that will energize the reversing valve in the cooling mode to put the heat pump into cooling. It is very important to understand all these different symbols and how they operate on a system, and the wiring diagram will tell us that. All of your wiring diagrams will have a legend, because sometimes there will be things that you may not recognize and won't know what they are. And so the legend will tell you what a device is so that you can identify it on the wiring diagram. You may have seen this wiring diagram on a NATE certification test. On the NATE test, the question was, when is the crankcase heater energized? I'll pause a moment here to let you try to figure it out before I tell you. In this wiring diagram, the system is off. The CR relay is de-energized, so the contacts to the contactor coil are open, and the contacts to the crankcase heater are closed. The temperature switch to the crankcase heater closes at 65 degrees. So the crankcase heater is energized when the system is off and the outside temperature is below 65 degrees. By understanding how the symbols depict various switches, you can understand how the system operates. For example, the temperature switch closes on temperature drop. So anytime the temperature is above 65 degrees, this switch will be open. When the temperature drops below 65 degrees, the switch will close and remain closed until the temperature goes above 65 degrees. Whereas on the high pressure switch, this switch will be activated when the pressure rises, and so the switch will open when there is high pressure in the system. Conversely, the low pressure switch will close when the pressure rises and will open when the pressure gets low enough to open the switch.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.